Hello everyone, welcome to my first video. So in this channel I'll be sharing more details about more practical things about the data processing, machine learning, artificial intelligence and regarding topics. So in this first video I'd like to discuss something about the data and the magic because since every analysis that we do, the basic source of information is the data. So I'll be talking more and more about the data and what types of data we have, what are the different classifications we can do, what are the different processes in which the data can be obtained, can be sought out, and in what categories or classifications we can do so that it can be easier for us to analyze them in the long run. Again, one more thing that many people get easily confused with or jumbled up with is what are the programming languages out there which will actually help in this. So, as you might have seen, read, or heard about that, obviously, when you are doing data processing or data engineering or machine learning, everyone goes out after Python. True, Python has grabbed the whole world and has been a target for a lot of people. But there is again one programming language which is called R. Okay, so this R is basically a statistical tool which will actually help you in getting the statistical information from the data for processing. Yes, there are statistical tools in machine learning using NumPy, SciPy, and other libraries. But again, R has other some advantages, some disadvantages, and some places where you can easily use R, some places where you can easily use Python. So I'll be discussing that as well. Okay, but this video primarily will focus on the types of data we have, on the formats of the data, on the various processing or the various ways in which the data that is obtained can be classified, so that when each classification of data that you have, when you start your processing, then you understand that okay, if we have this class of data, then what type of processing can be done, so that you can easily get the information from the data that you have, so that you will be able to understand, you'll be able to make the machine understand that what type of data it is, what to do with the data, how to analyze the data, how to retrieve much better information from this data, how to or as I like to say it, how would you perform the magic on the data that you have. So this magic that you would perform on the data will depend on what type of data it is, on which category will you be able to put it in. So if you put it in the correct category and if you follow the correct steps or procedures in that category, then you'll be able to do a lot better. You'll be the, as we say in India, the PC Sarkar of the data. So you'll be able to do lots of magic on the data. You'll get much more information from this type of data than anyone else. Okay, on that note, let's start. So as you know that so when you're computing data, when you're getting the data in different forms, so these are the basic forms that you can get the data in. So people use WhatsApp, Facebook, etc. So in them we have many types of data. So we have the text. Obviously, when you're typing something, when you're sending it to someone, you have the text data. Second, you are clicking some image, clicking some photos, taking some snaps of the picture of the surroundings of yourself, etc. Then you have the image data. Third is the video. So again, people are skeptical that saying that video is a different form of data because it can again be broken down into two parts. One is the image and the audio. So, but how can that be possible? Because video is a continuous, right? And images are basically separate images you click. So, what you can do is, so in the video, the images that you see have something called as the FPS system or the frames per second. Okay. So, our eyes have the unique capability to distinguish between two frames when the time difference between those two frames is actually less than or more than, you can say, zero point 0.1 second. That means we are able to distinguish between two frames of images when the frames per second rate is about 10 or maximum 15. Okay, depending on the eyesight of the person, depending on the interpretation of the person, but this is the standard rate. Okay, but if it goes above that, that means you are seeing at a faster rate. That means per second you are seeing say 20 or 30. Like in the movies have a standard FPS of 20, 25. Sometimes when you are seeing something in very high resolution or very high speed. Okay, then the high speed chasers that you see, they take something which is called the high FPS to make us feel that yes, the car is actually going at more than 100 kilometers per hour, while the car is actually going at somewhat around 25 kilometers per hour or 30 kilometers per hour, right? So there we use the technology of increasing the FPS so that you can feel that the car is moving very fast, but that's actually not the case. So that's how basically images can be broken down into video can be broken down into audio as well as images. So audio is again the plain form when like I am saying something or you are saying something. So that's again a form of data that you have. But next the question comes up that how would you classify the data, or what are the categories in which the data can be classified or can be sought out after. So this is the type 1 of classification. You can classify the data into multiple types based on what your basis of classification is. So in this type 1, the basis of classification that I have chosen is the structuring. Okay, so basically the data forms that I have showed you in this slide, the four major data forms, the text, image, video, and audio. So they can be again classified into these two, the structured and the unstructured. Before reading all this, let's just imagine what the word structured means. So structured, when you hear the word structured, again it comes from the root word of structure, right? So then when you hear something of structure, that means you give it a proper shape, a proper meaning, and a proper, a well-defined routine, you can say. Okay. So similarly, when the data is a structured data, that means the data will have a set of predefined rows and columns. Okay, the columns will be predefined and each of the column will have a separate meaning. That means no column will be given to you when you get the raw data that okay, this column meaning is undefined, that means you don't know the meaning of this column. That will not be happening because each column will have a set meaning, each column will again have a set rule to that which it will follow. Let me give an example in this. So suppose you go to a supermarket and you buy something. Okay. So in that, say a very small example if I take. So let's say three columns. The first column will be the item that you have bought. The second column will be the say the item quantity, and third will be the price that the item has. Okay, just a very basic example. So here every column has a set meaning, right? There is no column in this data which has a very weird sense that okay, I don't know what the meaning of this column, I don't know where it came from when you have the raw data. But suppose you are given the pre-processed data, then obviously the columns may not be of meaning to you, obviously because the processing has been done, some calculations have been done, then the meaning will change. Okay, then the meaning will be such in many cases we have seen in the past. It means when when I was doing it, that I didn't understand what the meaning of the data was or the meaning of the column was because the pre-processing had already been done, and not the raw data but the refined data I had got. That means I did not get to understand what the meaning of each column was, but that each column will have a set of rules that it will follow. So suppose in that supermarket example, the store example that I was giving you, so the item quantity will have the rule that okay, the item quantity column will be non-negative. That means okay, I can suppose I buy something which is free of cost, okay, but which is when suppose I go there, I don't want to buy this, I take it by mistake. So what the person will do it, suppose he swipes it at first, then I come to the notion that okay, I don't want it. So when he is swiping, it is +1. When it is swiping in, it is +1. But when it is swiping out, it's -1. So +1 -1 will give you 0. That means the item quantity can be 0, but it can never be -1. That means you are returning something. Many supermarkets don't accept that because again it may hamper their calculations and the stocks, etc. Many supermarkets don't have that. So let's assume they don't return anything. That means the set rule in that item quantity is that it will be non-negative. It can will be 0 or more than that. Similarly in the prices, okay, so you will have the prices also as non-negative. It can be 0. Suppose you are giving something for free, that's 0. But you're buying something for some cash, some credit, etc., then it has a certain amount. Okay, it will be always non-negative and will be 0 or more. So that's how you set the rule. Okay, but after you do some processing, suppose you take a monthly statement from your say the bank, and you want to analyze that, okay, on groceries how much you have spent, on transportation how much you have spent, like that you can do a small data analysis on your monthly budget. Then you can, so what will you do? Suppose then you do it for say 7 or 8 months. You collate the data and you take it in a small table. Again, this is an example of structured data, because each column will have a separate meaning, that okay, this is a column for expenditure, expenditure of this type. Suppose movies is one column, second column will be say you can say what example, what other examples can you think of? Say movies one is one example, one column. Second is say groceries. Third you can say vegetables. Fourth you can say miscellaneous usage. Fifth you can say transportation. So there's each column. Okay. Then in the each row you can give the month in which say January 2021, February 2021, March 2021, like that. So it will be a monthly analysis, and the each say the data value will be numeric, and obviously it will be non-zero, because obviously you are spending something on that. Okay, it will be zero or more. Suppose you don't go out, as in this COVID situation you're not going out, so transportation will be very minimal. Suppose you go to the supermarket and you have two very heavy bags which you won't be able to carry when you're walking, so you take a car or you take a bus or something, or some transportation, so that's going to cost you. So transportation cost will be very minimal. So then comes the analysis part. Okay, so this is the very raw data that you have. Now suppose you pre-process, so you do some processing on the data. Now the data has the data points, the values get changed. Okay, so then will the columns have the same meaning? No, because you've already done some processing on it. The columns meaning will change. The columns values will also change. So that's how the structured data in the raw form, when you get it in the raw form, each column will have a meaning. Each column will have a separate rule which it will follow. Coming to the unstructured data, this is a very you can say unexplored and a very wide open field that we have right now. So why is this a very wide open field, and why this data is very hard to process? Okay, so first, this has no structure in it. So this is like, you can say, water. It takes the structure of the container it has, as we know it. So you keep it in a jar, it takes the shape of a jar. You keep it in the pot, you take the shape of a pot. It has no structure in it. So the data that you have, you cannot put it into rows and columns in a very simple way. You have to do a lot of pre-processing to do it. Okay. Second, the interpretation of this type of data is very, very difficult. So obviously for a human mind, so when we are producing the data, we know what it means. But how do we make the machine understand that what this data is, what this data means? So that part is very difficult, and people have spent years and trying to come up with ways in which the structuring of the unstructured data can be achieved, because we have numerous methodologies through which structured data can be processed, can be analyzed, etc. But the conversion of unstructured data to structured data is very difficult. The third point is the analysis is very difficult, is very rigorous, you can say, and it requires a lot of domain knowledge and expertise. So what do I mean by domain knowledge and expertise is that, so suppose the unstructured form of data is say an audio clip. Obviously the audio does not have any rows and columns when you get it in the raw form. The shape of it looks somewhat like this, the mouth that is speaking, right? It's in a waveform, long, it has latitude and longitude, etc., right? So similarly, so like that, it is a very unstructured form. That means it has no rows and no columns. So how do we analyze that? How do we get the information from it? So there the person who has the domain knowledge can come and identify that, okay, this is the way you can actually get the information from the data. Okay, so suppose there are 7 or 8 people speaking. How do I identify that which voice? Suppose I give you a voice sample in which there are 7 or 8 people speaking. How do I identify that? Okay, this say the waveform of this person is this, and the waveform of that person is this. There is a mixture of voices, right? So here you need the domain knowledge or domain expertise. So that is why So one interesting fun fact I'll give you here, the structure. So till now we have around millions and millions of the GBs of data. We have petabytes of data, but we have only 2 to 3% of structured data till now, and most of the data that is lying around is unstructured data, and which comes around say 97-98%. And most of it, I can't emphasize more that this form of data, this unstructured form of data, is the untapped resource that we have. This form of data is what will be the driving force of future, because structured data, everyone, and I mean literally everyone who knows machine learning, the ABCs of machine learning, can understand that okay, this is the structured data I have, this is the predefined rows and columns, and these are the algorithms that I have. I can do it very easily. But for unstructured data, to convert that is going to be a mammoth task rather than just implementing the algorithms. That is why I say, I emphasize on the third point, that the analysis is very rigorous, is is very rigorous. Okay, so these are a few examples that I was talking about. So the dog picture that you can see, so people have the notion that images are actually unstructured data, but images are actually structured data. Why? Because suppose you get this image of the dog. Okay, so this particular image, so there is, so just to take an example, I've enlarged a very small portion of the nose and I've shown that what it actually looks like. So you can see here that it is basically broken up into pixels. Okay, so when these pixels are taken, so these pixels, so in row 1 column 1 I may have a red pixel, in row 2 column 2 I might have a blue pixel, like that. So that means there is a proper structuring, and then I will take this whole image and I'll get it into a single row. I'll stretch it into a single row, right? So that is one processing. So this is a very important thing to understand, that yes, this may look like an unstructured data but is actually a structured data. Okay, similarly, the second example in which we have the total defects, the A, B, C, D, E columns, this is a very good example of structured data, because already the structured data, the structuring has been done for us, and we have the data in front. The third example is the audio. So as I've been telling you, that audio is a very good example, the untapped resource of unstructured data. Phew. Let's come to the second type. The second type of classification is based on the output type that we have. Okay, so suppose the data that you have has some output variable. Suppose you go to, suppose as an example, I'll say, let's say a very simple example that many people are familiar with is the identification of a dog or a not dog. So suppose I give you an image of a dog, and the algorithm says that yeah, it is a dog. And suppose I give you an image of a cat, the algorithm will say it's not a cat. That means you know that okay, I know what I have to predict. I know I have to say if it is a dog or not. Okay, that means the data is has some predefined classes. So these are classes. Okay, so the dog is one class and not dog is a second class. Similarly, suppose if in the stock market, suppose I give you the stock report for the past 10 years of the company or 11 years of the company, then you can predict that okay, for the next 1 or 2 days, what will be the stock. Okay, so it has some numeric value. So it means you know that what its value will be. Okay, so this is this is called the supervised data. That means the data is, you can, so the output is known to you. Okay, of the training data. So again, data has basically three parts. Basically, some people say three, some people go with two, some people even have four. Okay, so I'll stick to three. So you have the training data, in which that data and every attribute of that data, so every column is known, the output may or may not. So if it's a supervised, then the output is known. If it's unsupervised, the output is not known. Okay, so that is training data. Second is the testing data, in which the testing data the machine has never seen. Okay, so that is what we need to check if the algorithm that we deploy is actually correct or not. Okay, but the training data machine has already seen. So how do we improve or know that yes, on the testing also it will work? So then that is where we come up with a validation data set, in which we tell the machine that okay, suppose this is a train that is given to you, you have trained all the parameters, everything on that data, and so this is the second data point that we have given to you, which is the validation data. Okay, So then you need to tell us that, okay, are you able to get the same performance or a good performance with the validation data or not? Then you do your analysis on the test data and deploy the algorithm. Okay, so that is one form. People again say that no, I don't have that much data, I'll only do a training and then a testing. So in the training data, again, you can feed the data in different batches. So suppose that you give it, say, you have say 10 GB of training data. So you give this software say 8 GB of data and you test or validate on the 2 GB of data that is remaining, and then you deploy the algorithm and test on the testing data. So that's one form. That's again, I'll come to that in a later video. But in this, let's talk about the supervised and unsupervised. So in supervised, the data will follow a certain pattern, the output type and the output range, you can say, is already known to you. Yes, here the computation will take time in the long run. That means if you have millions and millions of rows of data, yes, the output will take time. Okay, and in supervised data, some data is already available in the pre-training for the pre-training of the model. That means you have the data in which the output is predefined for you. Okay, so in which you already know that, okay, so this is the image, that this is a dog, and if that is the image, that is a cat. So you already know, and then you can train the algorithm, and then you can test it, etc. But the whole situation changes in the unsupervised. So unsupervised, you don't have any output which is defined, so in which the pattern of the data cannot be predetermined or prejudged. So when the data arrives, so it is impromptu. So it is prompt. When the data arrives, you can only then you can identify with pattern recognition. So here you have pattern recognition. Okay, the output type, the range, and other statistical elements of the data is pretty unknown to you. You don't have any clue of the what the data is right now, what the data will look in the future, like that. So the data is analyzed upon its arrival. So when the data comes to you, when you get the data, then only you can start your analysis. Then only you can group the data or cluster, as we said, the data into its respective buckets. Okay. Then you can understand and analyze that. Okay, so if I consider this group of data to be one class and that group of two data to be another class, and then suppose you get a new data, so then which is it nearest to, or which class can it belong to? Again, you have the ability of can, not should. Okay, that's a very different form. So this is an example that I've been talking about. So in supervised, you can see that that line has been drawn, that okay, we can identify that, okay, the blue dots that are there is class 1 and the orange dots that are there are the class 2, and I can draw an arbitrary line in between separating them, and the brown ones or the dark, I don't know what the color is, that ones are the unknown classes. That means you have to predict that, okay, what are these classes, what will be the classes of this. So obviously which is on the top right hand side will be in class 1, which is in the bottom right will be in class 2, as you can see from the eyes. But will that be the actual case? Again, you need algorithms, right? But when you come to the left image, which is the unsupervised, you don't know what the classes are. You don't know what is the actual scenario. So yes, you can see that there are two densely populated groups, but what about the data points in the middle? Where should it go to? And what and why should it go there? We can say that, okay, it will go to the top class or the bottom class, but why? This is a very important question that we need to answer. Okay, so this is one important aspect that people have been researching and people have had views on this. Okay, and suppose I give you a uh, very simple example that, okay, so you have a supervised data which is structured. The analysis is very simple. You deploy the algorithms, you do some pre-processing, you will get the output, you're happy with it. But the most hardest part is, suppose you get an audio, which is, again, as I told you, audio is non-structured, right? It is unstructured data, and suppose you don't know what class it belongs to. That means it is one of the most difficult places to be in, unstructured, unsupervised. Then how do you get the information? So this is the most horrible thing that can happen to you, but this is also the most researched upon, because the scope of research and scope of getting the information is tremendous. Okay, it is almost towards infinite of what you can do in this part of the data where it is unsupervised and unstructured. Suppose you get video, suppose you get audio. How do you from that unstructured get to structured? Then from that structuring, how do you get from the unsupervised to the supervised? Okay, how do you retrieve the information? That is going to be a very big challenge, but people have had breakthroughs in this is one of the vast fields of machine learning and data science, or whatever you can feel. Everything is interrelated here, but this is one of the field, and I can't stress enough, where some tasks have been done, some tasks are being done, and some tasks will be done, which will be, you can say, breakthroughs, okay, in machine learning. That was a lot of information to process, so I'll come to the last part of this video, in which we can say that, okay, since Fernando, you have talked about a lot of things, a lot of data, and give us time to process it, but how do we program it? Okay, so what you have data, so how do you program it? So people say that, okay, go with Python, go with R. So people have different opinions. So what do you prefer? You can go with R, you can go with Python. Okay, well, R is a bit difficult in the start because a lot of analysis, a lot of tools, etc. to be used, a lot of analysis has to be done, a lot of statistics has to be done. But Python is very simple to learn, simple to use. Okay, and even a 10-year-old, even a person in class 10 can code superbly in Python, but not in R. So R is a very scientific and a very calculative tool. Okay, yes, it is a bit slow learning. It will run locally, so you need to have a big machine if you want to run a bit bigger cluster of data, etc. In Python you can do it on the fly, you can do it on the cloud, etc. Okay, so Python is very good when it comes to deployment and production. Okay, but in R you can do the testing in a very small chunk of data. That, okay, this is the data that I have, say, of 100 GB in my local machine, which has a capacity of, say, 32 GB or 40 GB of RAM, of 32 or 64 GB of RAM. Let's say I take 32 GB and I do the data processing on the 32 GB. So I'll get the idea of the path in which I would like to go. So in the deployment or the production environments, then I can go and tell the people who are deploying it and saying that, okay, this is the path that I have chosen and these are the results that I've got, and this is actually where I can improve on. Or you can see in the production that, okay, how will it work on the larger sets of data? That's where R is beneficial. Python obviously does numerous benefits, numerous things. People have been working in for a very long time, and you can see popularity in programming languages. Obviously, Python is much more popular because it has a huge advantage over R. But mainly programmers and developers use Python. When it comes to R, people who are scholars, people who are doing PhD, or people who are into a bit of statistics, statistical analysis, will use R. So in the later sections, in the next video onwards, what I'll do is I'll start with R, because for people to understand that, okay, this is the way to go forward in Python, people need to understand what is the basis, or why do we need to go into Python, and what are the charts, or what is the analysis that needs to be done. So Python is very good for huge data, but for smaller data, to understand that, okay, this type of algorithm needs to be used, or this type of analysis is best, for that R is the most beneficial. Okay, so yes, the disadvantage is that there is a dependency between libraries. Python does not have that many libraries. Python's libraries are widely open. People have been, a lot of people, developers are there in the Python community, whereas very few people are there in the R community. Yes, both of them are open sources, etc. You can read the other advantages and disadvantages in this slide when you want. You can pause the video here. But yes, both of them have their own advantages, have their own disadvantages. Okay, so that's where you need to decide that, okay, what you are you going to research on the data, or you are going to just blindly go and develop it, or whatever has been done in the past on different sectors, you're just going to take those algorithms and deploy it. That I leave up to you. With that, I'll say thank you and kudos. See you in the next video. Thank you.